फरवरी मार्च 2021 एक ही वेरिएंट होता है, इससे स्टार्ट करते हैं। क्वेश्चन नंबर 1 जो है वो लॉगरिथम्स का है। यहाँ पे साइड पे लेबल भी कर देते हैं किस चीज़ का सवाल है। इट सेज सॉल्व द इक्वेशन ln ब्रैकेट is 3 ln x माइनस ln 3। अब यहाँ पर मैं एक डब्बा बना रहा हूँ कि कॉमन मिस्टेक्स क्या होती हैं। इसमें जो कॉमन मिस्टेक लोग कमिट करते हैं, बहुत कम लोग करते हैं मगर करते हैं, that is they open up this bracket ln x cube minus 3. Some people they open this up as ln of x cube minus ln of 3. This is simply not possible. इसलिए पॉसिबल नहीं है because there is no rule that relates that can make this bracket open up. अब ब्रैकेट ओपन अप नहीं कर सकते, तो एक तो ये कॉमन मिस्टेक हो गई। अच्छा, अब वर्किंग क्या करेंगे। ln ब्रैकेट x क्यूब माइनस 3 इज इक्वल्स टू 3 ln x माइनस ln 3। सबसे पहला काम इस 3 को इसकी पावर बनाएंगे, ये पहला रूल है। दूसरा काम, ये जो माइनस साइन है ये डिविजन के लिए है। सो देयरफॉर ln उल्टे हाथ as इट इज रहेगा, x क्यूब माइनस 3 इज इक्वल्स टू ln ऑफ x क्यूब minus ln of 3 which is ln of x cube over 3। तो ये दो रूल्स इस तरीके से लगेंगे, सिंपल सी बात है। अगली चीज़ क्या आएगी, अगली चीज़ ये आएगी कि आपका रूल क्या लगेगा, एक और रूल लगेगा, दैट इज के log of m base a if it equals to log of n base a, दो चीज़ों का log लिया जा रहा है, नेचुरली सेम बेस है, इसका मतलब है वो दोनों चीज़ें आपस में बराबर है। तो यहाँ पर जब हम बात करेंगे तो आप ln ले रहे हैं इसका, आप ln ले रहे हैं इसका, इसका मतलब है ये दोनों आपस में बराबर है। सो x क्यूब माइनस 3 इज इक्वल्स टू x क्यूब ओवर 3 विच इज 3x क्यूब माइनस 9 इज इक्वल्स टू x क्यूब। 3 minus 1 that is 2x cube is equals to plus 9. X cube is equals to 9 over 2 which is 4.5. Therefore x comes out to be 4.5 ka cube root. So cube root of 4.5 is the answer. Naturally you would take care of the accuracy. So this is question number 1. Let me go to the mark scheme. This is, let me double check, this is February, March, this is perfect. Now, the first thing that we are studying is the key messages. That is for the overall paper. What does it say? It says, candidates need to understand that parallel lines only require the consideration of directional vectors of the line. Now, this is with respect to vectors. Let's skip this part for right now. Let's go to that particular question. That is, comment on the specific question. We will read these two things once we are done with the whole paper, then we will read this. Now, comments on specific question. What does it say? Question number 1. It says most candidates were able to express this thing as this, convert this thing into this, then obtain a correct equation free of logarithmic terms. That means the logs disappear. However, a few candidates, I am always interested in the mistakes that people make so that we can avoid it. However, a few candidates mistakenly gave their final answer correct to 3 decimal places instead of 3 significant figures. So our level of accuracy is 3 significant figures, not 3 decimal places. That is one thing that should be taken care of. That means the mistake that I have pointed out as such, it seems that nobody committed that mistake in this particular paper. So that's a positive thing. Let's go back to the paper again. Question number 2. This looks like a question of remainder and factor theorem. So this is RF theorem. And now the question is the polynomial ax cube plus 5x square minus 4x plus b. Let fx equals to this thing. So ax cube plus 5x square minus 4x plus b. Unless and until there is a particular equation, how would I substitute the values in? So the very first thing is let fx, let hx, let gx equals to something. Acha, but they have already labeled it. It is denoted by px. So let me write this thing as px. It is given that x plus 2 is a factor of px. X plus 2 is a factor of px. And when px is divided by x plus 1, it's not a factor. The remainder comes out to be 2. So basically, it's a simultaneous equation question. First of all, what will you say? You would say p of minus 2. Whatever this bracket is, make it equal to 0. Therefore, x is equals to minus 2. Whatever this bracket is, make it equal to 0. Therefore, x is minus 1. So therefore, p of minus 2 equals to 0 because it's a factor. The remainder is 0. So therefore, a into minus 2 cube plus 5 into minus 2 square minus 4 into minus 2 plus b equals to 0. You simplify. This is equation number 1. Similarly, you would say p of negative 1, that is equals to 2. This is the remainder. A into negative 1 cube, 5 into negative 1 square, minus 4 into negative 1, plus b equals to 2. This is equation 2. And then when you solve simultaneously, you find the value of a, you find the value of b. Now, I don't think so there should be much in the examiner report regarding this. The examiner report says most candidates successfully identified that this question was best approach using the remainder factor theorem rather than long division. Now this is strange that some people must have tried long division also. So with two unknowns, long division, that was something strange that they did. While long division is perfectly valid, you would end up with two unknown constants. While long division is perfectly valid, the required arithmetic usually results in numerous errors. So the moral of the story is something could be valid, something could be the right method, but it all depends on which method is most suitable. That will give you the least number of errors. So this will give you a lot of errors. Most candidates correctly substituted, divided by the correct factors if using long division. So basically, examiner did not discuss anything about simultaneous equation because those who did simultaneous, they probably got it all right. Now, let's go to the third question. Now, the third question is, this is about trigonometry. So this is a trig question. And it says by first expressing tangent x plus 45 is equal to 2 cot x plus 1 as a quadratic equation in tangent x. Solve the equation x lying between 0 to 180 for 6 marks. Now, what is the rule that will be applicable over here? This is about addition formula, because this is tangent x plus 45. Tangent x plus tangent 45 divided by 1 minus tangent x tangent 45 equals to 2 cot x plus 1. Now initially I am not changing cot to tangent. I'll do that, but a little bit after a bit while. Tangent of 45 is 1, tangent of 45 is 1. Now I can write cot as 1 over tangent x. So this is 1 over tangent x plus 1. Let me simplify it on the right side also. 2 plus tangent x divided by tangent x. And on the left hand side, this is tangent x plus 1. And this is 1 minus tangent x. And the examiner have already informed you that you will be getting a quadratic equation, so don't be shocked by it. So now when you cross multiply, this is tangent x bracket tangent x plus 1. This is 2 plus tangent x multiplied with 1 minus tangent x. So when you multiply it, this is tangent square x plus tangent x. This is 2 minus 2 tan x plus tan x minus tan square x. Take all the terms on the left hand side. This is 2 tan square x, and this tangent cancels off, and take that one on the other side, plus 2 tangent x minus 2 equals to 0. Always make a habit of double checking it. So let me double check. Tan, and this thing tan square plus tan x, that is perfect. 2 into 1 is 2. 2 into minus tan x is this. Tangent x into 1, tangent x into negative tan square x. This plus this is 2. These two have the same sign on opposite side of equal sign. That's why it cancels off. This minus becomes a plus. This plus becomes a minus. That's perfect. So now the equation is tangent square x plus tangent x minus 1 equals to 0. It might factorize. It might not factorize. We don't know about that. So try your luck. Try factorizing it. If it factorizes, it's perfectly fine. Otherwise, quadratic formula is already there. So now when I apply quadratic formula, I'll get values of tangent. Now let me go to the mark scheme and let me grab some quick answers from there. So this is question number 3. And this is in question number 3. And then when you solve it, it says solve a 3-term quadratic equation for x. Let me just copy paste this thing. So I'll take it from here. And let's focus on this. Now it says use correct trigonometric formula to obtain an equation in terms of tangent x. That is done. Use tan 45 equals to 1. Obtain a horizontal equation in tangent x. Now this term means everything in the numerator. Horizontal equation. Reduce the equation to this thing. This is exactly what we are getting. Solve a 3-term equation for tangent x. Obtain answer such, and no other in the interval. That means if you give extra answers, marks will be deducted because you have to take care of that particular range. So basically what you are getting is that tangent x equals to something, and the answer is between 0 to 180, and tangent x equals to something else. Most probably this is the scenario. One positive value, one negative value. How can I say that? I can say that based upon the answer because it's 0 to 180. So if it's positive, it would be first and third. If it's negative, it's second and third. But two answers are coming in. That means one is coming from positive, one is coming from negative. So if this is positive, basically in the first quadrant, theta equals to alpha. If this is negative, in the second quadrant, theta is 180 degrees minus alpha. Alpha is the basic angle. You always calculate it with a positive ratio. That means over here, if it's negative, you would still calculate it with a positive value. Okay? So that's how this particular question is done. Question number 4. This looks like a differential equation question. So this is differential equation. And then we will see what knowledge of integration is required. It says the variables x and y satisfy the differential equation such and such. Let me do the variable separable first, dy and 1 over y dy. There is only one y term, that is equals to sine x divided by 1 minus cosine x dx, integration. Now two formulas are applicable over here. Two integration techniques. Formula is not the right word. Integration technique is. That formula is, first of all, you would say integral of 1 over ax plus b dx. There is a constant at the top. If the constant is 1, perfectly fine. If the constant is something else, take it outside. 1 over ax plus b, that is 1 over a ln ax plus b plus a constant of integration c. And if the need arises, actually there should be a modulus sign over here. This is the rule number 1. What is the rule number 2? The rule number 2 is, if there is a derivative at the top and an original function at the bottom. In other words, if the numerator is the derivative of the denominator, then the integral is ln of denominator plus a constant of integration. In reality, this is one rule. That second thing, the one written in pink, that is the real one. What we have done is that for a linear expression, we write it separately so that we can recognize it easily. And in general, we can write it like this. Fx could be any function. It could be trigonometry, it could be exponential, it could be anything else. So basically, on the left hand side, what is happening? That the orange formula is applicable. On the right hand side, what is happening? That the pink formula is applicable. Technique is applicable. Now, when you solve such a question, first make the right decision. Do not start in a hurry. Think again. Consider everything. Decide on the technique once you have done the variable separable part. Then start. So now everything is set. It's a straightforward question. This is 1 over 1. What is this 1 in the denominator? This 1 is basically for the coefficient of y. Because look over here. What does it say? This is ax. So this is 1 over a. A lot of people, they miss out this part. 1 over a ln ax plus b. Make a habit. Even if the coefficient is 1, still write 1 over 1. Because when it's not going to be 1, you're going to be forgetting it. So that's why always write it. So first of all, this is 1 over 1 ln y. And this thing, 1 minus cosine x, is the numerator derivative of 1 minus cosine x? The answer is yes. The derivative of 1 is 0. Minus sign remains as it is. Derivative of cosine is minus sine x. Minus minus cancel. Everything is set. No adjustment is needed. So this is ln 1 minus cosine x plus a constant of integration c. Again, I am re-emphasizing, on which side do we put the constant of integration? We usually put it on the right hand side, because usually whatever is on the left hand side, that is being made the subject. It's not a matter of right or wrong, it's just a matter of convenience. If I would have written a plus d over here, and that plus d goes on the other side and becomes minus d, so this minus d will exactly be equal to plus c. So don't worry about that. Now they are asking us, solve, obtain an expression for y in terms of x, and a lot of space is given. This is too much. And then in the end it says sketch the graph. That means the equation will become something that we know how to sketch. Since we are dealing with the trig function, most probably it could be a trig graph, it could be sine, cos, tan, it could be sec, cosec and cot. Okay? So that's how you do the futuristic thinking. So now let me proceed. So first of all, now two options are there. Should I evaluate the constant first and then make the subject? Should I make the subject and then evaluate the constant? So usually I have a habit of first evaluating the constant. So it says, given that y equals to 4 when x equals to pi. So y equals to 4 and x equals to pi, 1 minus cos of pi plus c. Cos of 180 degrees is negative 1. So cos of 180 degrees is negative 1. So therefore this is ln 4, this is ln 2 plus c. This is ln 4 minus ln 2 equals to c. This is ln 4 over 2. Again, rule of log. That is equals to c. Therefore, c comes out to be ln of 2. Now, rewrite. ln y is equals to ln 1 minus cosine x plus ln 2. So now this question becomes like our first question. We are basically simplifying it. So therefore this is ln bracket 2 1 minus cosine x bracket closed, that is equals to ln y. There are two terms of ln, one on the left, one on the right. So therefore these two are equal. Therefore y is equals to 2 minus 2 cosine x, or I could simply write this thing as 2 bracket 1 minus cosine x. So now I have a lot of space left because I did not commit any mistake, because I thought everything from before. It says sketch the graph. So y is equals to 2 minus 2 cosine x. Write this thing as negative 2 cosine x plus 2. So first of all, what do you need to draw? You need to draw a grid. You need to draw negative 2 cosine x. So first of all, just draw a rough graph. This is cosine x and this is one cycle. So negative 2 cosine x should be something like this. And this should be negative 2. This should be positive 2. And this should be 2 pi. That is one cycle. And let me label 5 major points. 1, 2, 3, 4 and 5. And then what will you do? You have to shift the graph up by 2 units. So let me extend this line a bit, and this thing is 2 and this thing becomes 4. So this value goes over here, the 0 value goes over here, the 0 value goes over here, minus 2 goes to 0, minus 2 goes to 0. So therefore this one is the graph of the equation for this differential equation. Now I hope you remember that when we were doing a differential equation, and if you have watched all the lectures, especially the initial ones, at that point I re-emphasize that a lot of time examiners are not asking for a long period of time. They were not asking any sketch. Now they have started to ask that sketch. Remember the question about the population of infected rabbits, or that chemical question in which exponential graphs were there? So make a visit to that lecture again and go over that topic once again, because what I foresee, because I have just seen the first variant, March 2021. I have not seen the June papers, the November paper, or the March 2022. Maybe they have asked more sketches. Maybe they will ask more sketches in your paper. So question 4 is done. Now we are back to question number 5. So it says express root 7 sine x. Another trigonometry question. So now this time it is a harmonic form. So that is what we call it, the harmonic form. Or it's also known as the compound angle formula. It says express root 7 sine x. So this is root 7 sine x plus 2 cosine x in the form r sine x plus alpha, where r is positive and alpha is acute. State the exact value of r, that means the third form. Give alpha correct to 2 decimal places. Naturally you have to use the calculator. Now this is of the format a sine x plus b cosine x. Remember, when we have the first term as sine and we are starting with sine, that etiquette should always be followed. So that's why the first is always a and the second is always b. The first coefficient is always a, the second coefficient is always b. What is r? That is a square plus b square under root. We always take the positive value. That is root 7 square plus 2 square. 49 plus 4, that is 53. My bad. This is 7 plus 4, that is 11. So that is root 11. And what is alpha? Alpha is tangent inverse of second coefficient over the first. We always take the positive value, even if b is negative or a is negative or both are negative, we ignore that minus sign. So therefore this is tangent inverse of 2 over root 7, whatever the calculator gives to you. So that's how the first part is done. The second part, hence solve the equation for theta between 0 and 180. Now this time what has changed? Instead of theta or instead of x, there is 2 theta. The original question is in terms of x. They have replaced it with 2 theta. That means if I write this equation, this is root 11 sine x plus some value of alpha. So this time it would become root 11 sine, instead of x it will be 2 theta, only this thing is changed, plus alpha, and this is equal to 1, and now this becomes a P1 trigonometry question. You would write sine bracket 2 theta plus alpha is equals to 1 over root 11. It's a 4-step process. I'll simply write down the steps. The first step is about quadrants. That is the first and the second quadrant. We are dealing with sine. Second step is about modification of range. So now let me go back to that particular thing. This is question number 5. And if I go down and get some angles. So question number 5, you are getting 37.09 and this thing is 17 point something. So this is 37.09 and this alpha is 37.09. Let me use this value, and this one is 17.5484. 17.5484. So this thing, first of all, let me focus on the range. 2 theta plus 17.5484. Before that, theta lies between 0 to 180. 2 theta lies between 0 and 360. 2 theta plus 17.5484 lies between 360 plus 17.5484, and this thing is 17.5484. Now third step, that is basic angle alpha. This basic angle is different from that alpha. So you over here you would write sine of alpha equals to 1 over root 11, and I think I have messed up a small mistake. Actually this is not 17.54, this is that thing, that is 37.09. So this is 37.09. So this is 2 theta 37.09, 37.09. This is 37.09. And sine alpha equals to 1 over 11. Alpha comes out to be 17.5484. So now the mistake is corrected. And last but not the least, working towards the final answer, 2 theta plus 37.09. The first quadrant is 17.55. For simplicity, I'm writing 17.55. 180 minus 17.55. Now what should I take care of over here? I should take care that are these two answers lying within this particular range or not? Is anyone cancelling out? Yes, the first one is cancelling out. This first one is in the first quadrant. You have the liberty of going more. So therefore 17.55, add 360 to this one, and that would take care of it. Once you have done this, and then naturally in the end you make theta the subject of the equation, and then you are ending up with 2 answers. Question number 6. This is a question of which topic? It says so. This is partial fraction, and the second part could be binomial. The second part could be integration. Let's double check. The second part is integration. So partial fraction and integration. It says let fx equals to such and such, where a is a positive constant, fx in partial fractions. 5a over 2x minus a, and then it is 3a minus x. This is identical to something. Now look at the factors in the denominator. In the first factor, the x is written first. In the second factor, the x is written later on. Okay? You have to take care of it. Second thing, they have used the symbol for a, the alphabet A. So don't use A even if it's a capital A. There are 25 other alphabets. So use B and C. So this is B over 2x minus a, and this is C over 3a minus x. Now take LCM. This is B, 3a minus x. This is C, 2x minus a. No need to write the denominator because of course the denominators are equal. This is equal to 5a. Now eliminate any constant one at a time. But before that, there was something that we should have checked, which we forgot. That is, we should have checked whether this is a proper fraction or improper. Numerator, it's a constant. Denominator, there are 2x. So this is like after multiplication, the power is 2. So therefore, yes, it's definitely a proper fraction. So you can start right away. Second thing, you should also state which case is this. So this is denominator with linear factors. So now let's get started again. Let x equals to, I'm starting with 3a. Because if I start with 3a, this thing would disappear. So therefore, 5a is equal to b into 0 c into 2x minus 3a. So I think I'm just taking. If I take x equals to 3a, I should be plugging it in place of x. So this is 5a, that is b times 0, c times 2 into 3a minus a. So therefore 5a equals to 6 minus 1 is again 5a multiplied by c. Therefore c comes out to be 1. Let me choose another value. So 2x minus a equals to 0. Therefore x is equals to half a. So x is equals to half a. 5a equals to b 3a minus half a. C is multiplied with 0. 5a is equals to 2.5a multiplied by b. Therefore b comes out to be 2. So b is 2 over something. C is 1 over something. What is that something? 2x minus a. That's the first one. And this one is 3a minus x. So now this partial fraction is done for 3 marks. Now it says that we are going to integrate it. So integration of this thing, let me rewrite it, 2 over 2x minus a. This is 2 over 2x minus a. And this is 1 over 3a minus x. We have to integrate it between the limits a and 2a, and the answer is exactly in terms of constant. Not only it's exact because it's in terms of ln and it's a constant, there is no a left. First of all, write this thing as 2, and this is 1 over 2x minus a. Yeah, I can start right away. This 2 goes on the outside, and 1 over 2x minus a, this looks better, dx. And over here, this is 1 goes on the outside, 1 over minus x plus 3a. I have broken it up. I'll assemble it very soon. This 2 as it is, this is 1 over 2 ln 2x minus a. Bracket closed. 1 over negative 1, because of that negative x, ln negative x plus 3a, and no need to write constant of integration because you're going to put in the limits very soon. So this is ln 2x minus a. This is negative ln. Now if you want to rearrange, shuffle, you can write 3a minus x. Again a minus sign. I think this rule has come for the third time. ln a minus b, that is ln a over b in this particular paper. This is ln 2x minus a over 3a minus x. Now plug in the limits a and 2a. ln 4 minus 1, that's 3a at the top, and there is an a at the bottom, minus ln 2a minus a, that's a, and 3 minus 1, that's 2a. That is ln 2a minus ln half, actually 3. That is ln of 3 because the a cancels off, minus ln of half. Again, the fourth time, the minus sign is there. Actually, it's an extension of that. So therefore, this is ln 3 divided by half. Therefore, this comes out to be ln of 6. So that is the working for this part for 4 marks. Question number 7, vectors. So now, vectors, a very simple question of vectors. It says two lines have equations such and such. So line 1, let me write in the expanded form. R is equal to 1 plus 2s, 3 minus s, 2 plus 3s. That is line 1. Line 2, R is equals to 2 plus t, 1 minus t, 4 plus 4t. It says show that the lines are skew, and then it says find the acute angle between the directions of the two lines. So let me do the first part. 1 plus 2s equals to 2 plus t, that is equation 1. 3 minus s equals to 1 minus t, that is equation 2. Leave the third equation aside. So basically there were 3 equations. This is equation 1, this is equation 2, and this last one is equation 3. So if I want to solve 2 equations, let me make s the subject from equation 2. Minus s is 1 minus t minus 3. That is minus 2 minus t. This is negative s. Therefore, positive s is 2 plus t. Then plug it in the first one. 1 plus 2 times 2 plus t. That is equals to 2 plus t. 1 plus 4 plus 2t is equals to 2 plus t. 2t minus t, that is t. And 2 minus 5 is minus 3. T is minus 3, therefore s is 2 plus minus 3, that comes out to be negative 1. So let me rewrite s as negative 1, t is negative 3. Now plug in equation 3. What is equation 3? 2 plus 3s, is it really equal to 4 plus 4 times t? So s is negative 1, that goes here, and t is negative 3, that goes here. So therefore minus 3 plus 2 is negative 1, and minus 12 plus 4 is minus 8. These two are not equal. So you would write a statement, since s and t, the parameters, do not satisfy all 3 equations, therefore the lines are skewed. That is the working for this part. Now let us pick up the direction vectors. 2 minus 1 3, 1 minus 1 4. 2 minus 1 3, 1 minus 1 4. This is direction vector 1. This is direction vector 2. And they are asking us acute angle between the direction of the two lines. So basically dv1 dot dv2, that is magnitude of direction vector 1, magnitude of direction vector 2, and this is cosine of theta. So 2 minus 1 3, dot product with 1 minus 1 4, that is equals to multiply 2 into minus 1, 2 into 1 and minus 1 into minus 4 and 3 into 4. So therefore this is 2 and this is 1 and this is 12 bracket closed into cosine of theta. So therefore this is actually on the left hand side, my bad. This is 2 plus 1 plus 12 and this is square root of 9 plus 1 10 plus 4 14 16 17 18 and this is cosine of theta divided by root 14 root 18 is cosine of theta. Naturally the answer will come out to be acute. If it so happened that the numerator may be, if numerator is negative and examiner asks for acute angle, then remove a negative sign from numerator. So naturally your answer will come out to be acute. Question number 8. Complex numbers. Now there are 3 aspects of complex number. Of course the examiner will either ask primarily on 1 or maybe maximum on 2. It could be algebra, it could be trig, it could be loci. So let's look at the whole question. The complex number u and v are defined by such and such. Find u over v in this form. So this is the algebraic perspective. Hence express this thing in this form. This is algebra to trig. And naturally the exponential form also. This is the exponential form. And then it says in an Argand diagram, the points represent the complex number such and such, state the geometrical relationship. This is basically O-level math. Vectors. Part D, there are 2 ways of doing it. One is the concept of complex numbers. The other one is the concept of scalar or dot product. I'll focus on the scalar or dot product. I'll briefly mention how can you do it using complex. So now technically loci was not asked and trigonometry was asked just a bare minimum. So basically it's an algebra, a very simple question. It says u is minus 4 plus 2i. V is 3 plus i. We have to divide. So therefore minus 4 plus 2i, you can write on the side u over v, divided by 3 plus i, multiply and divide by conjugate of denominator. So therefore this is 3 minus i, 3 minus i. Right on the side, what do we mean by the conjugate? If a complex number z is a plus bi, always the real first, then the imaginary. Therefore z star, the conjugate is a minus bi, you change the sign of the imaginary part. What else is there? Any complex number divided by its conjugate, you get a real number. So you get a square plus b square, why a plus? Because I square is minus 1. So let's get started. Minus 4 into 3, negative 12, minus 4 minus I, plus 4i, 2 into 3, that is 6i, 2 into this thing, minus 2i square. This is the numerator. Let me first simplify the numerator. Minus 2i square becomes plus 2. Plus 2, negative 12, that is negative 10. 4 plus 6, that is 10i. So now let me focus on the denominator, that is 3 square plus 1 square. This is not Pythagoras theorem. Do not apply the square root. Divided by 10, so it's a straightforward, beautiful answer. That is minus 1 plus I. This is u over v. Second part, express this thing in this particular form. First of all, there is no direct way of going it. So you have to first convert it into the trigonometric form, then you would write it in the exponential form. First of all, what is the trig form? The trig form is z is equals to r bracket cosine theta plus I sine theta. And then you simply summarize it, r e I theta. So first of all, draw -1 plus I. This is -1. This is I. This is imaginary axis. This is real axis. And then you would draw it like this. Something like this. And first of all, calculate the basic angle. This is the basic angle alpha. And the required angle is theta. So first of all, tangent of alpha is 1/1, the imaginary over the real. Ignore the minus sign. And of course, you would be working in the radian form over here. Therefore, theta is pi minus pi by 4, which is 3 pi by 4. What else do I need? I need the magnitude. So modulus of z, which is defined as r, that is equals to the real square plus the imaginary square under root. So therefore this is 1 square, this is 1 square under root, this is root 2. Remember, it has nothing to do with I. This is just like an O-level maths vectors question. So now what do you have? First write root 2 cosine bracket 3 pi by 4 plus I sine 3 pi by 4. Then or summarize it further, root 2 e I 3 pi by 4, and that is the answer that the examiner is looking for. Now it just says 2 marks. Okay? Sometimes the examiner is not so just about it. So very few marks for this, at least 3 to 4 marks should have been there. The working is simple, but it's not short. Now let's move to this part. It says the origin is O. A represents the complex number U. So basically, let me write OA in a vector form. What is U? U is -4 plus 2i. So this is -4 and 2. And the other one is 3 plus I. This is denoted by B. So V is actually B. And what is C? C is 2U plus V. So first evaluate 2 times U. So OC is 2 times U plus V. I'm working in the column vector form. U is -4, 2. This is 3, 1. This is -8 and 4. This is 3, 1. This comes out to be -5 and 5. This is OC. Now what does it say? State fully the geometrical relationship between OA and BC. Now OA is already given. This is OA. And BC, what is BC? Again O-level maths. So BC is OC minus OB. OC is -5 and 5. OB is 3, 1. That comes out to be -8 and 4. Now when it says geometrical relationship, that means it's talking about something with vectors, parallel, ratio of the length, scalar multiple, things like that. So BC is -8, 4. Can I further simplify and take 4 common out and write this thing as actually 2 common out? So take 2 common out and write this thing as -4 and 2. The answer is yes. Why have I written 2? Why have I taken 2 common out instead of 4? Because I have to compare it with OA. So if I have to compare it with OA, what is OA? -4 and 2. So I need OA inside. So therefore, I have proved that BC is 2 times OA. Write down 2 things. Don't leave it as it is. First of all, vector BC is parallel to vector OA. That's the first thing. What is the second thing? The second thing is magnitude of BC divided by magnitude of OA. It's in a ratio of 2:1. So BC is twice as long as A. Now over here this is positive. So write one more thing. It's in the same direction, about parallel and same direction. If this constant was negative, it would be opposite direction. Now let's move to the angle part. Now prove that angle AOB is 3/4 pi. Now what is OA? OA is the vector which is u. So OA is minus 4, 2 or minus 4 plus 2i. Instead of OA, let me first write this thing as u, the original form. And what is V? V is 3 plus I. And we know that u is denoted by A and V is denoted by B. That means I'm first showing you the difficult way. The first difficult way is if I draw an Argand diagram and I label u as minus 4 and 2i. So that is in the second quadrant, minus 4 and 2i, something like this. So this is your point A. And V is 3 plus I. So 3 plus I is something like this. So this is B and this is A. And what angle are they asking me? They are asking me AOB. So what you can do is that you can calculate two arguments, two angles. This is theta B and this is theta A. And angle AOB is actually bigger minus smaller. Tan inverse imaginary over real, tan inverse imaginary over real. That's one approach. So this is method 1. I personally like the second approach, which is basically dot product, scalar product. OA is a minus 4 and 2. It's not a 3-dimensional vector, it's a 2-dimensional vector. The rule remains the same. OB is 3 and 1, minus 4, 2, dot product with 3, 1, that is magnitude, cosine of theta. So therefore this is minus 12 plus 2. This is 16 plus 4 is 20. This is 10. This is root 20. Root 10 is equals to cosine of theta. And they don't say anything about, actually they say AOB is 3/4 pi. They have already given us the answer. Because I was focusing on this thing that since the overall sign is negative, the angle is obtuse. They have already given us the answer. So therefore, the numerator is negative 10. Denominator is root 20. So can I write this thing as root 2, root 10 like this? I can. This root 10 would become 10. So this would cancel off with this. So therefore cosine of theta is 1 over root 2 with a negative sign. Basic angle comes out to be 45. Or actually you can just use the calculator directly. Why basic angle? So therefore theta comes out to be 3 pi by 4. Because 1 over root 2 is the trigonometric ratio for 45 degree. Because of the negative sign, the angle is obtuse. Question number 9. This looks like iteration. The first part, second part is again iteration. Third part, this time this is differentiation also. So it's 2 iteration and 1 differentiation. So this is a combo of numerical solution of equation as well as basic differentiation. It says fx is such and such, x is positive. The equation has one root denoted by a. Verify by calculation this root lies between such and such. First of all, x equals to fx. X equals to e to x plus 1, e to x minus 1. Transfer everything on one side. X minus this bracket e to x plus 1, e to x minus 1 equals to 0 or equals to this thing, let's call it another function gx. Now you are saying that the root alpha lies between 1.0 and 1.5. So evaluate g of 1.0, evaluate g of 1.5. One of them would be positive, one of them would be negative. You would write a statement. Since there is a change of sign, therefore root lies between 1.0 and 1.5. That's how you would write it. Now, it is necessary that you transfer everything on the left hand side. It is necessary, otherwise this method fails. This is called the change of sign method. Let's look at the second part. Using an iterative formula based on the equation in part 1. Have they given us any iterative formula? They haven't. But we have to form one. Use an iterative formula based on the equation in part A. Determine A correct to 2 decimal places. Give the result of each iteration correct to 4 decimal places. Where is the iteration formula? This format over here can be written as the iterative formula. It could be x minus the box, or it could be box minus x. Both are workable. So if I just copy it as it is, we write this thing. Actually, the first one is the iterative formula. X is equals to fx, not everything on one side. So you would say x equals to e raised to power of 2x plus 1, e raised to power of 2x minus 1, n plus 1, n and n, because it has to be of the form x n plus 1 is a function of xn. So this blue thing that I've highlighted, that is basically for the change of sign method. The formula is basically given over here because x is equals to fx. So over here you replace it with x. Now what do? What should be your starting value? The best bet is, unless the examiner has specified it. If the examiner has already told you start with this value, you start with this value. Otherwise, you start with the mid value. So the mid value between 1 and 1.5 is 1.25. So the initial value is 1.25. You write x1 is 1.25. Therefore, this thing, fxn, that is e raised to power of 2 times 1.25 minus 1, e raised to power of 2 times 1.25, actually plus 1 at the top, minus 1 at the bottom. You evaluate this answer correct to 4 decimal places. And then you repeat the process. x2 is this particular value. Therefore, x3 is some other answer. And when you will see that the answers are converging, they seem to stop at a particular value, round it off to 2 decimal place, and that will be your final answer. Third part, f prime x. fx is e raised to power of 2x plus 1 over e raised to power of 2x minus 1. Which method of differentiation would be applicable? That would be quotient rule. So u is 2x plus 1, e raised to power of 2x plus 1. V is e raised to power of 2x minus 1. U prime is 2e2x. V prime is 2e2x. Since this is a quotient rule, always write at the top so that you know exactly where to start. Quotient rule is vu prime minus uv prime divided by v square. So therefore, you start with this and you would write 2e2x bracket e2x minus 1. Minus sign in the middle. And then you would again multiply 2e2x bracket e2x plus 1. This whole thing is the numerator divided by e2x minus 1, the whole thing square. So now this becomes, should I first take common? Yes, you should. 2e2x bracket e2x minus 1 minus e2x minus 1. The whole thing divided by e2x minus 1 whole square. I'm not opening up the denominator right now. This thing and this thing cancels off. This negative 1 becomes negative 2. This negative 2 into 2, that is negative 4e2x divided by e2x minus 1, the whole thing square. We are not solving for stationary point, they are solving for exact value. That will be in terms of E. And f prime x is equals to negative 8. So therefore, minus 4 e to x is equals to negative 8 into e to x minus 1, the whole thing square. First of all, get rid of this negative sign. Also get rid of this 4 1s are and this is 4 2s are. Now let's open up the bracket. E to x, that is 2. E to x, the whole thing square, minus 2 into e to x plus 1. Therefore, this is 2 e to x, the whole thing square, minus 4 e to x plus 2. And take this e to x on the other side. So therefore, this is 2 e to x, the whole thing square, minus 5 e to x plus 2 equals to 0. What kind of equation is this? This is an equation, an exponential equation, which will become quadratic. So let m equals to e to x. Therefore, m square is e to x, the whole thing square. So therefore, this is 2m square minus 5m plus 2 equals to 0, and I think it will factorize. So therefore, this is 2m square minus m minus 4m plus 2 equals to 0. m 2m minus 1 minus 2, 2m minus 1 equals to 0. 2m minus 1, m minus 2 equals to 0. Therefore, m equals to half. Therefore, m equals to plus 2. Does it say one answer or two answer? One answer. Let's see. Now it says m is e raised to power of 2x equals to half. E raised to power of 2x equals to 2. When I take ln of both sides, ln e raised to power of 2x is ln of half. Therefore, this is minus 2x ln e. This is ln 2 raised to power of negative 1. So therefore, minus 2x is minus ln 2. Therefore, x comes out to be ln of 2. And over here, ln e raised to power of 2x is, where does the minus come from? I don't think so there's any minus. So there is no minus over here. I think I was thinking on the other side, there is no minus. Therefore, there is a minus over here. And this is ln e to x is ln of 2. 2x ln e is ln of 2. Therefore, x is half ln 2. And I missed the 2 also over there. So there is a 2 at the bottom. This 2. Now, which answer is applicable? Let's go to the original question. Is there any hint that will tell me which answer is the only applicable one? That is, x is greater than 0. So both answers were working fine. This you have to reject and this you have to accept. Now let's look at question number 10, which I think hopefully is the last question. Yes, it is. And this is just a general question that has not exactly the same thing, but the same type has come at least 5-6 times before. So this is integration, this is differentiation, this is like product of two trig functions, and a similar graph was always given. What are the first things that we should observe? The first thing that we should observe is that whatever is m, most probably it's a maximum point. It lies between 0 and pi by 2, and there is only one answer. What else should we focus on? That is integration. So it's our choice which part do we want to do first. Let me do the differentiation part first. Sine 2x cos square x. Y is equals to sine 2x and cos square x. The previous question was about quotient rule. This one is about product rule. So let me also write product rule. Differentiation of uv, that is uv prime plus vu prime. What is u? That is sine 2x. What is v? That is cos square x. Now this question looks simple, but there is too much working over here. When I start differentiating, first thing first, do not open it up using double angle. Differentiate on the face value. Sine 2x, u prime is 2 cosine 2x. V is cos square x, chain rule. V prime 2 cosine x power 1, derivative of cosine x is minus sine x. That is the first thing. Y prime, that is minus 2 cosine sine multiplied with sine 2x plus cos square x multiplied with 2 cosine 2x. Now I can tell the examiner, let S denote sine x and C denotes cosine x. I am not using any symbol for sine 2x or cosine 2x. Now, should I take anything common out first, or I think let me first write this thing. Let me first expand it using double angle. And about this, I am unsure which of the three formats is applicable. So don't worry, leave it as it is. First, if I multiply, this is minus 2 sine cos, this is 2 sine cos, this is cosine square, this is 2 cosine 2x. That's the first thing. What should I take common out? I think I should take common out cos square from here. I should take common 2. Take this 2 common. This is cosine, this is cosine. So therefore, if I take 2 cosine square common out, what am I left with? I'm left with this 2. I'm left with sine. I'm left with this sine. So therefore, this is negative 2 sine square. Let me double check. 2, 1, 2 is inside, 1, 2 is outside. Cos square is outside, sine square is inside, minus is inside. Perfect. And over here, this thing disappears because that's taken common out. And this is cosine 2x. So that's the first part I've done. Next part. 2 cosine square remains as it is. Minus 2 sine square. Now I have a very clear-cut idea which format of cosine 2x I should use. Therefore, I should use 1 minus 2 sine square x. Is that the one? Acha. Is there anything, any other constant that needs to take common? I think this is all set. So this thing is 2 cosine square minus 2 sine square plus 1 minus 2 sine square. That is 2 cosine square 1 minus 4 sine square. Double check. Is it all good? Now they are interested in stationary points. So stationary points, dy by dx equals to 0. 2 cosine square 1 minus 4 sine square equals to 0. In all similar problems that we have done before, I have already told you that your answer would be from the bracket on the inside. Of course, you have to show why it's not on the outside, but it's just something for fun. So therefore, 2 cosine square equals to 0, cosine square equals to 0, cosine equals to 0, cosine is 0 at 90 and 270. So therefore, x or theta, which is the variable x is 90, reject, x is 270, reject. Both are rejected. Now, when you solve this, 1 minus 4 sine square equals to 0, 4 sine square equals to 1, sine square equals to 1/4, sine is equals to plus minus 1/4, which is half. So it's a beautiful, straightforward answer. Sine x is equals to half, therefore x is 5/6. So now the second part is done. Let's go to the first part. The first part is integration. And in integration, they are using the technique of substitution. Now, what is the first rule of substitution? The first rule is whatever is used first, do not look at the question, just look at the substitution and get started with that. U is equals to sine x, therefore du is equals to cosine x dx. That's the first thing. Now, look at the question. Integrate 0 to pi by 2 and you have sine 2x cosine square x dx. That's the first thing. Sine 2x is 2 sine x cosine x, and I'm writing this thing as cosine x and dx. Why? Because cosine x dx, this thing and this thing, this is your du. That's the first thing. Second thing, this thing, this cosine and this cosine, that becomes cosine square x. But cosine square x is 1 minus sine square x. Sine x is u, so this is 1 minus u square. So this thing becomes 1 minus u square. And then last but not the least, that is sine x itself, that is naturally u. So now everything is converted except the limits. So now focus on the limits also. X is 0, so u is sine of 0, which is 0. X is pi by 2, u is sine of pi by 2, which is 1. So the limits are 0 to 1. So simplify. This is 2 on the outside. You have u, you have 1 minus u square, and this is du. So this is u, 1 minus u square du. Don't be in a hurry. First multiply, then integrate. So this is 2. This is u minus u cube du. This is 2. This is u square over 2 minus u power 4 over 4 between the limits 0 and 1. This is 2 as it is. 1 over 2 minus 1 over 4 minus 0 minus 0. So half minus 1/4 is 1/4. 1/4 into 2 comes out to be half. So that's a beautiful answer. Half square units. That is the area. Actually, I shouldn't. They're asking for the area. Yes. So I should use the unit. Half square units. That's the area under the graph. And let me double check. No, there is no more question. So that finishes February-March 2021 P3 paper. Stay tuned for more.